What's up, scholars? Let's continue our investigation of types of probability with our example. Number 3, about a businessman taking a train. Businessman takes the 8 a.m. train to work 20 days in a month. He's surprised when the train arrives late in New York 3 of the 20 days. Should he be surprised? Describe how to conduct a simulation to estimate the probability that his train arrives late 3 or more out of the 20 days if New Jersey's transit claim is true. Well, let's remind ourselves, what was New Jersey's transit claim? That the train was on time 90% of the time. So to conduct our simulation, we're going to have to, what did we say our step 1 was? Define some events and assign some numbers. All right, so if 90% of the time the train comes on time, we need to assign 90% of our numbers for the simulation to indicate that the train is running on time. So let's let the numbers 1 through 9 indicate the train is on time. And we'll say the number 10 equals late. So we're going to do a simulation where we get some random numbers. Where we get some random numbers. And every time we get the number 1 through 9, that means the train was on time. And if we get the number 10, that means the train was late. So we'll use our random number generator. Use a random number generator. To get these random numbers, we're going to select 20 numbers to simulate the 20 train rides. Okay. So we're getting 20 numbers randomly from our random number generator that are simulating our 20 train rides. This will be one simulation. This is one simulation. All right, we're going to want to run this several times, many times, to get a better picture of what's happening. But each time we do the simulation, we'll pick 20 random numbers between 1 and 10. And we're going to keep track of the number of 10s we get, the number of late trains we get. So keep track of the number of late trains, i.e. number of 10s in the simulation. Alright, so there's our simulation we're going to use to try to determine whether 3 days out of the month of late trains is wild, is that crazy, or is that like pretty common. So this dot plot down here shows the number of days in which a train was late arriving in 100 repetitions of this simulation. So we did this thing 100 times. We used our random number generator to select 20 numbers between 1 and 10 100 times. And we kept track of the number of 10s, or the number of late trains we got in each one of those simulations. So this dot over here on the 7 means in one simulation we had 7 10s show up in our random number generation of 20 numbers. So in one simulation, 7 out of the 20 numbers was a 10, meaning 7 out of 20 times the train was late. In one simulation, the train was late 7 times. So, what's the resulting estimate of probability from the simulation? Well, we're saying, what's the probability his train arrives late 3 or more times? Okay, we got to add the or more in there. Because if he's surprised the train's late 3 times, it's definitely going to be surprised it's late 4 times, 5 times, 6 times, 7 times. So we got to look at all of those. So let's draw a line down here. So everything to the right are late arrivals that this businessman would be surprised at. How many times did this happen? So we had one simulation where there was 7 late arrivals. There were a bunch with 5 and 4 and 3 late arrivals. So let's count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There are 30 times out of our 100 in which the train was late 3 or more times. So the probability of having 3 or more, 3 plus late trains per our simulation was 30 out of 100, or 0.3, or 30%. That's pretty likely. 30% of the time something happening, that's pretty likely. So he really shouldn't be surprised. He should not be surprised. What's the threshold for being surprised? If it was less than 5%. It could happen less than 5% of the time. So if less than 5%, it is surprising. That's generally our threshold for determining if something is significant or not. If it's really out there or not. But 30% of the time, that's not surprising. All right. We can also find probability using our combinatorics, meaning our permutations and combinations. So, let's talk about that. Sometimes it's easier to find theoretical probability using combinatorics rather than listing and counting all the likely equal outcomes. Combinatorics include the fundamental counting principle and ways to count permutations and combinations. So, for example, there are 20 pets available for adoption. 7 are cats. What's the probability that Miss Hill adopts 2 cats and 2 dogs when she goes to the animal shelter if she selects 4 pets randomly? So let's think about how many sets of 4 pets could Miss Hill adopt. Does order matter here? No, definitely not. So that means we're going to use a combination. Use combo because order doesn't matter. Okay. How many pets can she choose from? 20. How many is she choosing? 4. Plug that into our calculator and we get 4,848. This is our sample space. This is our sample space. Okay. Our sample space for all possible outcomes. All right, let's keep cruising on. How many ways could Miss Hild choose 2 cats? And how many ways could she choose 2 dogs? Well, how many cats were there? There were 7. So 7 choose 2. Plug that into our calculator. We get 21 ways to choose 2 cats. How many dogs were there? There were 14. 14 choose 2. Plug that in and we get 91 ways to choose 2 dogs. Okay. Wait, hold on. There were 20 animals. 7 were cats. 20 minus 7 is 13. Sorry. So this should be 13 ways to choose 2. 13 choose 2 is 78. So there's 78 ways to choose 2 dogs. All right. What is the probability, then, of adopting 2 cats and 2 dogs if she selects them randomly? So the probability of 2 cats and, meaning plus 2 dogs. Okay. That's going to be choosing 2 cats times choosing 2 dogs over our sample space. So we want 21 times 78 over our sample space, which was 4845. So let's plug that in. 21 times 78 divided by 4845, and we get 0.338. That's the probability that she's going to adopt 2 cats and 2 dogs if she selects her pets randomly. Okay, cool. All right, last example. Janine is picking 3 songs to play Friday after school. 12 songs have been submitted, 3 of which are by the Backstreet Boys. Got it. If Janine selects her songs randomly, what's the probability that none of the songs are by the Backstreet Boys? So first we got to figure out our sample space. What are the total possible options here? Total possible options. How many songs are we picking? It's going to be 3 out of how many? 12. Does order matter here? No, it's a group of stuff. So we're doing a combination. 12 choose 3. Let's plug that in. 12 choose 3. And we get 220 ways to choose 3 songs, period. Okay, this is our sample space. Sample space. Now, how many ways could she choose a Backstreet Boys song? Well, there's only... Oh, we want probability that they're not Backstreet Boys songs. So there's 3 Backstreet Boys songs, so that means there's 12 non-Backstreet Boys songs. So 9 choose 3 is our probability of not choosing a Backstreet Boys song, which is 84. So that is the ways to not choose the Backstreet Boys, who were very popular when I was in high school, middle school, really. More of a middle school thing. Yep. So let's find our probability of no Backstreet Boys. This is going to be our ways to choose no Backstreet Boys over our total ways to choose songs, period. 84 divided by 220. 84 divided by 220. So that is 0.382. So 38.2% of the time, there will be no Backstreet Boys action if she chooses the songs randomly. All right, scholars, that's it. Keep on that hustle. Keep up the good work.